Welcome all. I'm here to explain about hydroboration-oxidation reaction, oxymercuration reaction, along with demercuration reaction. Hydroboration-oxidation reaction. It is a two-step hydration reaction that converts the alkene into an alcohol. And this process mainly results in syn addition of hydrogen and the hydroxyl group where the double bond is being present. This hydroboration oxidation reaction is an anti-Marconic reaction, that is addition reaction of alkene or alkynes where proton is being added to the carbon atom that has the least number of hydrogen atom attached to carbon. And with the hydroxyl group attached to the less substituted carbon, the reaction thus provides a more stereospecific and complementarily regiochemical alternative to other hydration reactions such as acid catalyzed addition and oxymercuration reduction process. This reaction was reported by Herbert T. Brown, which had Nobel Prize in 1979, in which this is the reaction, general reaction, in which tetrahydrofuran, that is THF, is used as a solvent here. And we can see that in the first step, borane, that is BH3, gets added to the double bond, which transfers one of the hydrogen atom to carbon which is adjacent to the one, and this hydroboration is being repeated 2 additional times so that BH bond gets reacted so that 3 alkenes adds to each BH3, and it results in trialkyl borane, which is treated with hydrogen peroxide in the second step. And in this process, boron carbon bond is being replaced with OH carbon bond, and this boron reagent is being converted to the boric acid, which is a mechanism. And the second step is the oxidation reaction, in which a nucleophile hydrogen peroxide anion attacks the boron atom, in which the alkyl migration to oxygen gives the alkyl borane with the retention of stereochemistry. Next, let's see what is an oxymercuration reaction. An oxymercuration reaction is an electrophilic addition reaction in which the alkene is being converted to the neutral alcohol, and this alkenes reacts with mercuric acetate in aqueous solution so that it gives the acetoxymercury group and hydroxy group which is present in the double bond. And here no carbocation is being formed, so no rearrangement is being observed here, and this reaction obeys Marconic rule, that is the hydroxyl group will be always added to the more substituted carbon, and it is a anti-addition reaction in which the two groups will be trans to each other. This is a reaction procedure, reaction step, in which we can see that oxymercuration, which is being followed by the reductive demercuration, which is called as oxymercuration reduction reaction or oxymercuration demercuration reaction. This is the mechanism for oxymercuration reaction. Here we can see that in the first step, the nucleophilic double bond is being attacked with the mercury ion, which produces an acetoxy group, which ejects an acetoxy group here, and the electron pair which is being present in the mercury ion attacks a carbon on the double bond, which forms a mercurionium ion, in which this mercury ion on the mercury atom will have the positive charge. And in the second step, we can say that the nucleophilic water molecule, that is which get attached with the more substituted carbon, which liberates the electron, and this electron collapse with the mercury ion and gets neutralized. So the charge is being neutral, it get neutralized, and here we can see that oxygen in the water molecule will have the positive charge, so that in the third step we can see the negatively charged acetoxy ion, which is formed in the first step, attack, and it attacks the hydrogen of water group, which forms the acetic acid, and the two electrons which is participating in the bond between oxygen and the attacked hydrogen collapse into oxygen, which neutralizes the charge and creates the final product, that is alcohol. Here we can see the final product, alcohol. Next is demercuration reaction. The mercury which is being present there is then removed using the sodium borohydrate, that is NaBH4, so that it reduces acetoxy mercury group and replaces it with hydrogen. And this is a reaction, demercuration reaction. We can see OH is acetoxy mercury is being replaced with hydrogen, and the combination of this oxymercuration which is followed by the demercuration process is known as oxymercuration reduction reaction. So far we have come across what is an hydroboration oxidation reaction, its process and its mechanism. What is oxymercuration reaction, its mechanism. What is demercuration reaction and its mechanism. Thank you.